Okay, so we're gonna finish up the review today. And I would like to start in chapter 3 exam review. There's only 7 slides for this particular presentation, so we should be able to get through it pretty quick. All right, so we're going to talk about radical and rational exponents. And a radical, of course, is a root. So we've talked about things like the square root of 4 or the square root of 5, and those are radicals. You could have the cube root of 7, anything like that, the fourth root of 8. So anything like that is a radical. All right, rational exponents, which are related to a radical. Rational means fraction. So anything that can be written as a ratio of 2 integers is a rational number. So it's some a over b, where a and b are elements of the integers, which they use j for integers. I don't know why, but they do. And b can't be 0. So we're going to talk about exponents that fit that particular form. All right, so here are your laws of exponents again, which we talked about last Wednesday. This is slide 3 in this deck. I don't remember what slide it was in the previous deck, but you can look that up. Okay, so here are the 2 definitions you need to deal with rational exponents and how they pertain to radicals. So A raised to some rational number m over n is by definition, the nth root of a to the m. So the denominator of this rational exponent is the root you're taking. And then the numerator is whatever you're raising that number to. Now, by definition, that's also equivalent to taking the nth root of a and then raising that to the nth power. It's the same value. All right. If n is even, then a has to be greater than or equal to 0 if it's a real number. So since you're taking an nth root, you can't take the even root of a number that's negative if you're interested in real solutions. So this happens to be, by definition, if you're interested in real numbers. So a has to be greater than or equal to 0 if this needs to be real. Now, if a is less than 0, that means you're going to get an imaginary number. Okie dokie. So now we can rewrite expressions that are being raised to rational exponents using this definition. So a to the is a to the m over n, or a to the m over n is the nth root of a to the n power. Okay, so what's x to the 1/7? The denominator is the root you're taking. So you're taking the 7th root of what? X to the 1st power, which we can just write as the 7th root of x. Okay, how about 144 to the 1/2? This is the square root of 144, and we don't write, this thing is called the index. So this number right here me write it over here where we can see it. That number right there is called the index. This thing underneath the radical symbol is called the radicand. If the index is 2, we don't write it. If there's no index, then we understand it's the square root. So you know what the square root of 144 is? Your calculator can tell you. 12. Because 12 times 12 is 1. Okay, then how would we write a to the 3/7? Well, the index is the denominator, so this is the 7th root of what, a to the 3rd? How about 16 to the 5/2? Is that the square root, which I don't need to write, of 16 to the 5th? And that actually has a value. And the reason I know it has a value is, again, from the definition up here, I can actually write this as the square root of 16 raised to the 5th power. By definition, we can do that. And the square root of 16, you may not remember, but that is actually 4. So what's 4 to the 5th power? Oh, we'll find out. So 4 to the 5th. 1024. So we can take values that are being raised to fractional exponents. We can write those as radicals. Conversely, if it's written as a radical, we can write it as a value raised to a rational exponent. So we could write the cube root of 20. Again, the index is the denominator. And whatever this power is, whatever that power is, in this case, it's 1. Whatever that power is, that's what the numerator is going to be. So what is this? Is this 20 to the 1/3? And how about the square root of 5? Is that 5 to the 1/2? 5 to the 1/2? It's a square root, so the index is 2. We got a power of 1 inside that radical in the radicand. So it's 5 to the 1/2. And as a matter of fact, the cube root is a to the 1/3. Square root is a to the 1/2. 4th root, etc. is a to the 1/4, etc. Okay, so let's continue. Write each of the following expressions in simplified exponential form. See if I can turn my volume down. I'm getting an echo and it's driving me crazy. Maybe not. Just continue to go nuts. All right, so we have the square root of x to the 3rd. And again, this is the numerator. PowerPoint on the iPad.
Technology's annoying.
That's crazy. All right, let's try this again. Okay. So we have the square root of x to the third. See if we can do this again. That is the numerator. The index is the denominator. So this is what? X to the 3/2? Yep. What's this one gonna be then?
X to the 3/7.
X to the 3/7. And what's this one going to be?
X to the 3/8.
X to the 3/8. Now you might be able to simplify these. For example, this one, you might be able to reduce or simplify once you've written this to the exponential, the rational exponent. So this would be 27 y to the 9th raised to the 1/6 power. 6th root is 1/6 power. And by definition of exponents, if we raise a product, so that's a factor, as is that. If we raise a product to a power, we can raise each factor to that power. Should be a times. And then we might be able to simplify. And you may not know this, but I talk about being able to know, you should know some perfect squares, probably up to 100. And you should probably know some perfect cubes also. And for example, let's write it up here. 2 cubed is 8. So the cube root of 8 is 2 because 2 cubed is 8. 3 cubed is 27. 4 cubed, and then I get kind of lost after this. I think that's 64. And 5 cubed, I think that's 125. And then 6 cubed, I don't know. I don't remember. But I do know up through 5. So I know the 27 is 3 cubed. So this is 3 cubed being raised to the 1/6 power times y to the 9/6. So this is 3 to the 3/6 times y to the 9/6. Now, can you simplify those two fractions? If you can't do it in your head, you can certainly use your calculator to see if they simplify. 3/6 is 1/2. And then 9/6, I think I can cancel a 3. 6 divided by 3 is 2. 3 divided by 3, 9 divided by 3 is 3. So is this y to the 3/2? Okay, and then we can do the same thing, well, something similar to this in B. In B, though, the 27 is outside the radical, so that's just 27. So it's 27 y to the 9/6, but we already determined that y to the 9/6 is y to the 3/2. So this is 27 y to the 3/2. Any questions? A copy of the review I made. We'll see how far we get in it. I mean, we're going to be in section 3.4, 3.3, excuse me, in 11 o'clock class, so. We may not get real far, we've only done two sections so far. See what we can do. Okay, problem one on your review. Give the coordinates of the vertex of the graph of the function. Graph the function on a window that includes the vertex. Y plus quantity x plus 1 squared plus 5. So what's the vertex?
Would it be?
What do you think it is?
The 5?
Well, 5 is the y coordinate of the vertex. That is correct. What's the x coordinate? See, this is the tricky part. That's why you're pondering. So the standard form of the equation of a parabola is y equals a times x minus h squared plus k. So k is the y coordinate of the vertex. That's pretty straightforward. But in the standard form of the equation of the parabola, what's inside parentheses, you're subtracting the x coordinate. So whatever is in here, whatever this is, the x coordinate of the vertex is going to be the opposite. So if it's plus, the x coordinate is minus. If it's minus, the x coordinate is plus because you're subtracting it. So is it -1?
Yes.
Okay, and now you should be able, from a process of elimination, figure out which one of these is the graph. You could also certainly graph it on your calculator. Is that what you're gonna do? They actually even give you what scale they want you to use, don't they?
Yeah.
Okay, so let's go y equals. Figure out what I have in there. So x plus 1 squared, open some parentheses, x plus 1 squared plus 5. And they tell me the window should be -10 to +10. -10. +10. I could have done a zoom standard. And then change the scale.
Okay.
Is that correct? Is that what they want me to do?
Yes.
That looks correct. Okay, so let's graph it. So which one is it?
C.
See? Yep. And I could have also, from the process of elimination, figured that out. It can't be that one. That's not a function. That fails the vertical line test. Parabolas open up or down. They don't open sideways. It can't be this one because this parabola, A is equal to +1, so it opens up. So it can't be that one. It can't be D because here the vertex, the x coordinate is positive because it's in the first quadrant. So x is positive. So that is, eliminate that one. All right. Problem 2.
Your screen's up on.
Oh, thank you. Need to share again, don't I? Actually, I should be able to stop sharing. So complicated. All right, is it back up?
Yep.
Right. To consider the function y equals 2x² plus 12x minus 12, give the coordinates of the vertex of the graph of the function. Graph the function on a window that includes the vertex. You could graph this first and figure the vertex out from the graph, or you can figure the vertex from the formula and then graph it. It's like 6 of one, half dozen of the other. I'm gonna find the vertex. All right, so the x coordinate of the vertex can be found by using the formula minus b over 2a. So b is the number in front of the x, so b is 12. And a is the number in front of the x², so a is 2. So let's plug that in. And so the result, the x coordinate is going to be negative. So we have minus 12 over 2 times 2. And my iPad's trying to help me. This is static electricity when it does that. So 2 times 2. Is that -3? So it's probably D, just by looking at the graphs. If x coordinate of the vertex negative, does it have to be D? I'm thinking. All right, so what's the y coordinate? To find the y coordinate, we evaluate the function at -3. So 2 times -3 squared plus 12 times -3 minus 12. So that's 2 times 9, -3 squared is 9, minus 36 minus 12. So 18 minus 36 minus 12. Is that -40? So the vertex is -3, -40? Or is that 30? Can I not add? Minus 18. That's 30. I can't add, I cannot. It's a good thing I have an eraser. 30. And you'll notice that I put the answer in the answer box using parentheses because it is an ordered pair. And in algebra, when we want to describe something as a point on the coordinate plane, an ordered pair, we put parentheses around it. Okay, so it has to be D, although you could certainly graph that. It's practice. Let's go ahead and graph it. Okey-dokey. So we have. Graph what I have in there. What do we have? 2x squared
Plus 12x.
and they do give me a window. Correct? -10 to 10. Which I think I already have, -10 to 10. I can change the scale to 1 if I want. It's neither here nor there, to tell you the truth. And then what's the minimum line? -40? And I might leave that scale at 2. So it is D. It's the only one it can be. Problem 3. The annual total revenue for a product is given by R of X equals 27,000 X minus 3X squared dollars, where X is the number of units sold. So X is units sold. To maximize revenue, how many units must be sold? So we need to find the vertex. This is a parabola. 27,000 X minus 3X squared. So the number in front of the X squared, that's my iPad helps me here. I always need to ground myself. I need to touch metal. Minus 3X squared. So the number in front of the X squared is A. And that is equal to -3. And since that is negative, this is a parabola that opens down. And so the maximum occurs at the vertex. Now you could graph this and find the vertex. I think the formula is easier, and the reason I think the formula is easier is because I don't have to figure out the window to graph this at. So that can be somewhat complicated to do. Back to my sharing here. All right, get back on track with the iPad. Okay, so the X coordinate of the vertex, which will be the number sold, is -b/2a. And we would expect this to be a positive number. It makes no sense for the number of units sold to be negative. So since A is -3, we already established that. B is the number in front of the X, so B is 27,000. So we have -27,000 over 2 times -3. And that is going to give you a positive result. Negative outside divided by negative, 2 negatives is going to make this positive. And I get 4,500 using my calculator. So if I sell 4,500 units, so that's the first field in this problem, then I'm going to maximize revenue. To determine what the maximum revenue is, we need to find the y coordinate. So we need to evaluate the function at 4,500. So we're going to plug in 4,500 for X. And my calculator says 27,000 times 4,500 minus 3 times 4,500 squared is, what'd you get? You get 60,750,000.
Yes. Problem 4.
The amount of a particular pollutant, P, in the air depends on the wind speed, S, among other things. With the relationship between P, which is the amount of the particular pollution, and S, the wind speed, is given by P as 29 minus 0.08 S squared, where P is in ounces per cubic yard and S is in miles per hour. Sketch the graph of this model with S on the horizontal axis and with non-negative values of S and P. So it looks like we're going to be doing a scale. All of these, except C, have a scale in the X direction from what, 0 to 20? So that's where I'm going to start. In the Y direction, what are we doing? From 0 to 30? The only exception is C, so we'll graph this and then we'll take a look and see if it's anything but C. Okay. So let's type that in. So I cleared out what I put in there earlier. So it's 29 minus 0.08 X. And we have to use X because our calculator didn't have an S. Is that correct? Put my glasses back on so I can see. And we're gonna go from 0 to 20 in the X direction. So let's go to our window, 0 to 20. And I think their scale is what, like 10? So we can make the scale match. And then what's the Y direction? What do we decide? 0 to 30? And what's that scale? 5, it looks like. And the scale is less important than the window. So which one is it? It looks to be A to me. Is that what that looks like to you? Wait a minute, where's it ending up down there? Well, the reason it's not A and the reason it's D is why? Tricky.
The P and S.
Because of the PNS. So it's D because we graphed S on the horizontal axis. We graphed S as X. So it has to be D.
That's what on my quiz, I redid it so many times and I keep on getting this question wrong and it must be my P and S.
Tricky they were. Okay, so what's the second part of this? Is the function increasing or decreasing on this domain? Well, a function, a parabola is decreasing if it opens down to the right of its vertex. And this thing has a vertex that's up here, and it is opening down. So it's going to be decreasing over on that side. The other thing is we can just see from the graph that the thing is decreasing because it's going down. Stop the share so we'll get back to our review. Sheet. So the function is decreasing. So we'll pick that from the drop down. What's the p-intercept of this graph? Well, where is it crossing the p-axis? Is it crossing at 29? So that number right there is 29. We also know that it's crossing the p-axis because if s is equal to 0, then P is equal to 29. So what's that mean? That means if the wind's not blowing at all, that the particulate level of this pollutant is what, 29? So which one is that? When the wind speed's 29, nope. When the wind speed's nope. When the wind speed, nope. When the wind speed is 0, the amount of pollution is 29 ounce per cubic yard. All right. Use the quadratic formula to solve this equation. All right, let's do that. I'm gonna write the quadratic formula up here. X equals minus B plus or minus the square root. The whole thing under the square root is B squared minus 4 times A times C, all over 2A. So I need to decide what A, B, and C are. A is the coefficient in front of the x squared, so it is the number 1. B is the number in front of the x, so it is 3. And C is the constant, which is -3. Make sure you take the sign with the coefficient. So let's make those substitutions. X is equal to -3. We're changing the sign of B, it's positive, so we make it negative. Plus or minus the square root. 3 squared is 9. I always square it either in my head or on my calculator and then write it down. And it's always positive. That first number underneath the radical is always a positive quantity. Minus 4 times A is 1, C is -3. The whole thing all over 2 times 1. So we have x is equal to -3 plus or minus the square root. And what do we have? We have 9 plus 12, is that 21?
Yes.
All over 2. And that is our answer. And there's nothing we can simplify here. The square root of 21 doesn't have any perfect square factors. I also encourage you not to simplify radicals. I will check, if it counts it wrong, I'll check it. And if you haven't simplified it, but you have it correct, I'll give you correct. I'll give you credit. All right, problem 6. Find the exact solutions to f of x equals 0 in the complex numbers and confirm the solutions are not real by showing that the graph of y equals f of x does not cross the x-axis. All right, I would use the square root formula on this. I take the square root of both sides. And when I do that, I get x minus 8 on the left. But on the right, I have to put a plus or minus. Whenever I take the square root of both sides, I have to put a plus or minus in front of the square root. And that's the square root of -36. Do you remember what the square root of -36 is? Well, 6 times. What's your calculator say?
Would it be 6i?
It is 6i. And it's 6i because, well, better put a plus or minus in front of it. I'm about to get it wrong. Plus or minus 6i. The square root of a negative is going to give me an imaginary number. So I know it's going to be something times I. And the square root of 36 is 6. So square root of -36 is 6i. And then just add the 8 to both sides. So move the 8 over on the right. So it's 8 plus or minus 6i. Now, I don't know. I haven't looked at a problem lately and I just forget. So when you do these in your homework, does it have a plus or minus in there in the toolbar?
It has plus or minus in the toolbar, but usually we have to write it like,
2 separate ones?
yes, like 6 plus 8, 8 plus 6i and then 8, then comma 8 minus 6i.
And that's fine. I'll check that too. If you put a plus or minus in there, that's okay. Not that particular. So this is going to be the last problem we're going to do because problem 8 we're going to do during the 11 o'clock class, and we're about out of time anyway. Using UN data from 1975 and projections to 2050, the number of millions of people aged 15 to 59 in a country can be modeled by y equals negative 0.224 x squared plus 20x plus 370.7, with x equal to the number of years after 1970 and y equal to the number of millions in this labor pool. Use technology, use your calculator, with the model to find when this population is expected to equal 724.3 million. So what you're trying to solve here is the equation where y, right there, y equals 724.3. So you could certainly write the equation, and I'm going to do that right here. 724.3 equals negative 0.224 x squared plus 20x plus 370.7. Subtract the 724.3 from both sides, and then use the quadratic formula. And it's looking icky already. So what I would do is I would graph in the y1 the negative 0.224 x squared plus 20x plus 370.7. And in y2, I would graph the 724.3. And then I'm going to find out where they intersect, because where they intersect is going to be the solution of that equation. So that's what I'm going to do. Share my calculator. And I'm not sure about the window. I might have to play with that a little bit, but that's okay. Okay, so we have a parabola that opens down negative 0.224 x squared plus 20x plus 370.7. And then in the other one is what, 724.3? So I do need in the y direction to at least go up to 750. Because that line is y2 is going to be a horizontal line at 724.3. So let's go look at the window. Okay, I'm going to leave that right now. Let's take that 50 in the x direction. I'll just do that. And then we're going to go from 0 to 750. That's a good place to start. And let's do a scale of 100. Okay, let's graph that. Oh, we got something wrong. Oh,
That looks different.
I've got negative 224 plus 28. Oh, I got an X missing in my 20. That's my mistake. So I'm going to go over there behind that 20. And I'm going to do an insert, second delete. And I'm gonna insert the X, and I think I've inserted it in the wrong place. We'll find out. I did. So 20. X. I just needed an extra space in there. Does that look correct now? I think that's good. Let's see what the graph looks like now. That's better. I just need to see the intersection. That's all I need to see. Okay, so the intersection is there, so we're gonna calculate the intersection. And do you remember how to do that? Second trace to the calculate menu. We're gonna calculate number 5, the intersection. First curve, enter, second curve, enter, guess, that's fine. So 24.3. So let's write that down. I'm gonna write it down, then we'll stop the share. So we intersect at 24.286. And what's the Y value?
724.
724. Okay. I think I intersect at another place. And I said I don't need to worry about it, but I think if this parabola comes up, it's gonna come back down and somewhere over here it's gonna intersect again.
Mhm.
So I need to go ahead and move that X scale out. So let's go back to our window and let's move this out to 100. And see if we can see where it's crossing. There we go. So the first intersection was when X is 24.286. And where's the second one going to be? So I'm gonna calculate that. I'm gonna calculate this intersection over here. So second, trace, intersect, enter, and then I just need to move the cursor somewhere fairly close to that intersection. 65?
Mhm.
So the model indicates the country's population is expected to be equal to 724.3 million in what years? Well, this is after 1970, correct? After 1970, let's highlight that. So we either have 24 years after 1970 or 65 years after 1970. And this is where the book gets interesting. Because the book says that 24.286, since we're talking about years, they want us to round it up to 25. I'm okay with 24 because I understand that you're gonna wanna round it down, but because it's 24 and a little bit more, they want you to round it up to 25. It's 6 and 1/2 dozen under the other. So I'm gonna round this up to 25 if I wanna follow the book. So would that be 20 years after 1970? That would be what? 1970 plus 25, is that 1995?
Yes.
And then 1970 plus 65? Is that 2015? Yeah, 2035? 2035. So the answer is 1995, comma 2035. Right on time. Any questions?
No. question on one of my homework problems.
Sure,
You want me to show you now or?
you can show me now if you want. Show me now. Want me to come back there so you don't have to unplug your computer?
It should be pretty charged now. It's